So this is FRQ of the day, number 1 from Tuesday. So today we're looking at, this is from the 2017 BC exam, and it was actually the same on the AB exam. This is question number 1. This was a calculator question. All right, so we've got this tank where it's going to give us the area of kind of the cross section of the tank at any given time. And then that changes as the height goes. So if you can kind of imagine, it's, it's kind of getting narrower as it goes up. So let's look at part A. It says a left Riemann sum to approximate the volume. First of all, here's why it works for volume, because we're going to be multiplying the base times the height. So that's volume. So for part A, what I do for a Riemann sum is I kind of sketch it out. And I'll say, okay, 0 feet, this is the height, 2 feet, 5, 10, rough sketch. I'll say, okay, this is 50.3, 14.4, 6.5, 2.9, just to kind of have an idea so I can see the boxes for the Riemann sum. And it's a left-hand sum, so my boxes are going to come from the left side, like so. And then I just need to find the area of those boxes. So that'll be the width. So the first box is 2 units wide, and the height is 50.3. Plus my second box is from 2 to 5, 3 units wide, height is 14.4. Plus this third box, 5 units wide, left-hand height is 6.5. And when you actually multiply that out, and you do have a calculator, so that's really nice, then your answer is 176.3. Now, you definitely need units. Always go back and read the question. It says indicate units of measure. Okay, so this is volume, and we got it by multiplying square feet times feet. So this is in feet cubed. All right, so there is your answer. Now, this one was worth 2 different points. So score yourself as we go. This was worth 2 points. You got 1 for having the left-hand sum. So like the setup of it, so were you multiplying these things? And then you got 1 point for having your answer. Now, also, not this question specifically, but throughout the whole FRQ, there was 1 point for units. And that included parts A, C, and D. So if you got any of the units wrong or forgot to put them, then you've automatically lost a point. So be careful with that. All right, let's look at part B. It says, is this an over or underestimation for the volume? Now, hard to know because we don't know what it looks like, so I'm going to read the problem again, see if there's anything useful in there. And I see this, that the function decreases. So picture this, we don't know how it decreases, but it's decreasing, and we did a left-hand sum. So if you could picture like boxes that are on the left side, where the left corner is touching, they're all going to be above the actual line. So this is going to be an overestimation because A is decreasing. And for this one, you got 1 point for your answer with the reason. You had to mention the decreasing part, or you would not have gotten that point, because that's how we know, okay? And you don't have to say anything more than that, by the way. So don't write a whole paragraph there, okay? Just decreasing. All right, part C says that the area is given by this function. So that's the area of like the cross sections as you go up. And we need to find the volume. Now this is kind of a throwback to stuff we did in AB with area and volume. We always use an integral. And in general, your volume is going to be the integral of the cross-section area. So oftentimes you have to actually find the cross-section area, but here they actually give it to you. It's this function. So you're just going to do the integral of that function, which is f of h. I'll put a dh for proper notation. And then I need to look at where does it go from? So where's my height go from? and my height goes from 0 to 10. You could think of this as adding up all of the slices between 0 and 10. So like as your tank or whatever is going up, I'm adding the area of this slice, this slice, this slice, this slice, this slice, all of them up from 0 height up to 10 height. That's the idea. Now, this integral, luckily, is something you can just solve in your calculator. So what I did is I put that function they gave me in for y1, and then I'm going to hit math and go to the integral and just put 0 to 10, and you can just put y1. I did alpha calc y1 dx, and once it calculates, I got 101.325. And again, we need some units. This is volume, so it's going to be feet cubed. Okay. Now, this was a 2-point question. You got 1 point for doing the integral. So you're kind of set up of the integral there, and you got your 2nd point for the correct answer. All right. Part D. For part D, it says water is pumped into the tank when the height of the water is 5 feet. The height is increasing at the rate of 0.26. So this is a related rates problem. So I'm going to write down height is 5. It says the height is increasing at a rate. That's dH dt. So dH dt equals what they say, 0.26. So I'm making my list of variables over here. And it says find the rate at which the volume is changing. So I am looking for dV dt. That's my question mark. So that's always the first thing I do is make this list of variables. And it said use the model from part C to do this. So if I look back at what I did for part C, because I'm like, what are they talking about? I'm looking for stuff about the volume, and it looks like in part C, I had an equation for the volume. I said the volume was the integral of this f of h area function, I guess from 0 to x. Okay. Or we could call it 0 to h, 0 to x, whatever. The point is volume is the integral there. So I need to find a way to plug in all this stuff. So I'm going to need to do the derivative of this. So derivative of v will be dv dt. Derivative of the integral is going to undo each other, and I'm just going to be left with f of h. But then because it's in terms of h, I need to put a dH dt, or sorry, I'm integrating or finding the derivative with respect to time. So my h thing needs a dH dt on it. Okay, then I'm going to plug in this stuff. So dv dt, oh, f of h, well, I know h is 5, so that'll be f of 5. dH dt is 0.26. Now, if you're wondering where do I get f of 5, remember that f of x was that equation they gave us back in part C. So I'm just going to plug in 5 to this equation. And actually, since I already have the equation in for y1, I can just do this. Alpha calc, I can put y1 of 5 and get 6 point whatever. So 6.517 times 0.26. Let's see what I get. I get 1.694. Now I need some units on this or I'm going to lose that point. So let me see, this was dV dt. So my volume unit was feet cubed over my time unit. Let's look back in the problem. Looks like, here it is, minutes, feet per minute. So it's going to be feet cubed per minute for my answer to part D. Now this one was worth 3 different points. So you can score yourself. You got 2 points for having your dV dt equation. So correctly taking the derivative of this. I do not know what partial credit was given on that, but I would imagine that there was some. Maybe for getting the dH dt or something. And then you got 1 point for having your final answer. All right, thanks for watching. Stay tuned tomorrow for another FRQ of the day.